I'm sure you guys are all familiar with the infamous A498 stepper motor driver for bipolar stepper motors used in so many CNCs and 3D printers and stuff. However, over the past few months, I've been building a 3D printer using unipolar stepper motors, and as it so happens, there is no plug-and-play motor driver for unipolar steppers out there. Well, there wasn't until now. In this episode of my $50 3D printer series, we're going to build the extruder using one of these dinky but super popular unipolar stepper motors called 28BYJ48. And because I've been touting the unipolarity of my steppers for ages now as though it was something super special, we're now finally building our own true unipolar stepper motor driver to go with it. This video is also sponsored by PCBWay, who kindly provided the printed circuit boards I'm going to need. Let's get started with the extruder design. To be honest, the design is really nothing special, basically a knockoff of the generic direct drive extruder, except it's going to be made almost entirely out of wood. And because those extruders are usually made from aluminum, I'll need some really tough wood to replace it. I glued up 2 layers of 5mm beech plywood to make up a single piece of 10mm ply, from which I can start machining the 2 most important and no less complex parts. The little spring-loaded lever that actively pushes the filament into the drive gear via the idler bearing, and the other stationary part I don't know the name of, if it even has one. Then I'll need some more rectangles of the 5mm stuff to mount the stepper on, and we're ready for assembly. First, I'm going to install a piece of 4mm dowel in both jaws, which will serve to hold the spring in place so it doesn't pop out. And as you can see, somehow the hole in the bottom one went in real crooked. No idea how that was possible on the drill press, but we can more or less fill it out with glue. Then, because I cannot be bothered with screws, I'll simply glue the static part in place. After all, we still need to put some screws through there later to mount it to the machine. While this is drying, let's figure out how to mount a pinch roller on the pivoting jaw. And I already regret this, but I have decided to make my own pinch roller from this scrap piece of mild steel. Why do I regret this decision? Well, A, it's a lot of work, but B, it won't have a bearing. Yes, you heard me right. There will be no ball bearing. Why? Because there's no space. Using wood, I need a lot more material for the same strength as with any metal, obviously. So I could have either made the entire extruder 5 times bigger to accommodate a proper bearing, or I could make some parts significantly smaller to achieve an at least adequate overall size. And because I couldn't spend anywhere near the amount of time I should have mulling over the best way to design every single part, that's where we are. Not gonna lie, this actually turned out awesome. Look at this thing. It must be the nicest pinch roller I've ever seen. I don't regret making it anymore. 3 hours well spent. Even better, I found this pin in my collection, which not only fits inside super snugly, but also happens to be exactly the right length. So I don't even need to cut it down before using it. Let's install it. Of course, the fact that I'm not using a ball bearing here is gonna add some unnecessary friction, and it'll likely wear out faster too. But the smallest ball bearings I have are 9mm, with this pinch roller being only 11mm and having a 1mm groove all the way around. Yeah, you can do the math yourself. Making a tiny grooved sleeve around an existing ball bearing would not have worked. For the extrusion gear, I actually went ahead and just bought a bunch. I originally wanted to make my own using a brass pinion like you can find on small DC motors, but I don't have any pinion I wish death upon, and ultimately I decided it just wasn't worth the hassle trying to drill out the hole exactly centered. Plus, a real extrusion gear has a lot more teeth that are likely also sharper than on a regular pinion. Using pre-made stuff is no fun. Spring from a soap dispenser pump goes on here. Then we jam in another pin as a pivot, and there we go. That's basically it. I guess now, more than a year after I bought it, I can finally break the seal on my Cyan PLA filament to try it out. The vacuum is long gone. Though I honestly don't know why it is falling to bits like that. Does this stuff come pre-packaged with plastic-eating bacteria? The idea is we jam the PDFE tube in this hole. For now it's just a friction fit. If that doesn't work, I'll have to come up with something different. Then you squeeze it together by these handles like a clothespin to stick in your filament. That actually works really well. I really like the feeling of this spring. It feels like just the right amount of force, although I have no clue what I'm talking about. But to try it out under power to see if it actually pulls the filament through like it's supposed to, we of course need to put together our unipolar stepper motor driver first. Now, I wrote the script for a quick explanation, and it turned out long enough to be an entire video of its own, so unfortunately, as much as it pains me to do so, we'll have to leave all the whys and hows for another day and just concentrate on the presentation today. I mean, we all know I basically needed an excuse to design another PCB. And as long as I'm honest about it, I see no problem with that. But fortunately, there's a little more to it, since converting unipolar steppers to bipolar in order to use the A4988, like I still am planning to do for at least the X and Y axis, has its limitations. Anyway, let's unbox our PCBs. I'm sure you guys can already guess the colors I've chosen. Put your guesses in the comments down below now. So, did you guess correctly? Oh, I got another pen! Well, the first one is here, by the way. Let's put those together. And here we have the circuit boards themselves. Yes, yellow, of course. And I'm sure they're the same awesome quality as always. This time I actually got 10 of them, because can you ever have too many stepper motor drivers? So, not including shipping, each of these came in at just 50 cents. Together with the components, my unipolar stepper motor driver is pretty much the same price as an A4988, which, speaking stepper motor drivers, is pretty darn cheap. These are every bit as beautiful as I expected them to be. Look at that. The real question though is, will this be the first time I ever designed a circuit board without screwing up? Because if you remember, the last time I tried this was a disaster. The footprint for the microcontroller was totally wrong, and that wasn't even my fault. So this time I triple checked the schematic, all the connections, and all the footprints. So will it actually work this time? Anyway, enough rambling. It is time I introduce you to Chronic Unistep, as I have fittingly decided to call this project. Chronic Unistep is a Gerbil and Marlin compatible, easy to use, so-called translating stepper motor driver. In other words, it takes the same direction and step inputs as the A4988 and converts it to the corresponding steps on any unipolar motor you connect. The motor is controlled in half steps. The maximum reliable microstepping, the 28BY-J48, and other generic low-resolution steppers you can salvage from eWays are capable of. It's actually a fairly simple circuit. If you guys are interested in this project, I might open source it. However, I really don't have time to maintain it or carry on development, and the current version 0.95 has a fundamental issue I wasn't able to resolve yet, inhibiting use on the X and Y axes of 3D printers. More on that later. But let's start gathering components to put it together. For translating the input signals, my circuit is based on the dirt cheap CD4017 decade counter, and because I never came across anything I could salvage 2 of those from, I did the only reasonable thing and purchased 50 of them. You know, shipping. The more I buy, the more it spreads over the total number of chips, making an individual IC cheaper. So we need 2 of those. Then to handle the motor current, we'll need one ULN2003. Fortunately, I have some of those in my collection, and since I designed my board to take both the DIP and the SMD version, I can use whichever I like. Next up, 500,000 of rectifier diodes, and by 500,000 I mean 24. It's a truly ridiculous quantity of diodes given the size of the board, and definitely the most unwieldy part of this design, but luckily you can use pretty much any small diode. Here I have tons of salvage 1N4148s, so that's what I went with. Then I need some 0603 SMD resistors and resistor networks, which I've taken the liberty of picking in advance, a few 100 nanofarad decoupling capacitors, and 1 PNP as well as 3 NPN transistors. Now here I'm using the MMBT 3904 and 3906, which are marked 1A and 2A in SMD, though I'm pretty sure you can use any SMD transistor with the same pinout. And lastly, I'm just missing 4 0603 LEDs. Unfortunately, my collection of SMD LEDs is still pretty sparse and mostly comprised of many individual ones rather than batches from different devices, so I'm gonna make an exception here and use brand new green LEDs I bought 5 years ago. With that said, let's populate the board! Also, I think this is the first real appearance of my homemade soldering station I finished 8 months ago. I've used it quite a bit off camera since then, and it's been a treat. Not a single time I've had the desire to return to the old commercial soldering iron. Now of course it's not all sunshine and roses. Just like with everything, I always find shortcomings or things that could have been done better, and in the case of this soldering station, it's clearly the wooden handle. It's still kind of overheating. Those of you who've been following my work since before my channel turned into yet another CNC channel might remember in episode 2 of the soldering station series I've had problems with too much heat creeping up into the handle, which I thought I solved by making the new one you're seeing me use right now, but as it turns out, after running for a few hours, the end closest to the tip still gets uncomfortably hot to touch. Now, clearly it wasn't enough of an issue for me to even consider doing anything about it anytime soon. In fact, I love using devices I've made myself more than anything, but as with everything, there's still room for improvement, and it's important to keep that in mind to be able to do better next time. Not gonna lie, soldering 0603 surface mount with the camera obstructing my view wasn't easy, but editing 3 hours of soldering down to 1 minute downright hurt. But never mind that now, it's time for the moment of truth. Will this thing work, or did I somehow mess up? Put your guesses in the comments now, but be aware I cannot remember ever having made a circuit board that worked first try. So I'm gonna play it safe now and say there's a 20% chance of it working, even though I see no reason why it shouldn't. Okay, everything's wired up. The Arduino is running the exact same sketch I already used several times with the A4988. It basically just puts out pulses for steps on pin 3 and controls the direction via pin 2. However, I already noticed my first mistake. The pinout on this plug does not match that of the 28BYJ. That could have been solved easily by flipping the connector before soldering it in, but I didn't, so now I get to reconfigure the pinout of the plug. That was a close one. It would not have worked. Let's try it now. Modified motor plugged in, and now my power bank. This looks good so far. Then if I turn the potentiometer, yes, it's working! No way. Look at that! Whoa! I cannot believe it! Oh my goodness. Look at that motor spinning both ways. That is unbelievable. See what I mean? Had I not caught the wiring mistake with the stepper motor, it would 100% not have worked. Now, you might be saying, but Benjamin, this stepper motor driver is awesome. Why can't it be used on all axes of a CNC? And the answer is, because of the way change in direction is currently implemented. One of these 4017 decade counter ICs does clockwise rotation, and the other one anti-clockwise. And sometimes switching between them makes the motor do a weird little jump in a random direction. In other words, sometimes it loses steps, or does additional ones it shouldn't have done. Now, that certainly doesn't matter for an extruder, and even for the Z-axis, at least as long as you don't have Z-hopping enabled, it shouldn't be a problem. But for an X or Y-axis that constantly runs back and forth and back and forth and back and forth, that one little lost step might just add up over time and lead to layer shifting. In theory. For the most part though, I think it wouldn't even be noticeable, but honestly, I have really no idea. I would need to do some real-world testing before jumping to any conclusions. That actually takes quite a bit of force to push that in there. Ah, broke again. Tell me in the comments, is PLA always so brittle, or why is that? Yep, works just fine. But it is skipping some steps at that speed. Okay, it kind of works. The motor is definitely struggling at higher speeds with a Bowden tube that long, which doesn't matter because I need to cut it shorter anyway. What worries me much more is how brittle this filament is. I can barely feed it in without breaking it. But anyway, let's finish the extruder. Because the 28BYJ48 is admittedly more of a toy than a real stepper motor, we can't really trust its bearings to take the force from the spring pushing the filament against the shaft all the time, so I made a cover to go on here, and it'll have a bearing in this hole to support the other end of the shaft. Yes, I am procrastinating cutting this off because I don't want to make it too short. And as much as this extruder design may be super compact, it'll probably end up being a huge pain to thread filament in and out because you literally can't see what's going on. And there we have it! True unipolar stepping on a 3D printer using unipolar stepper motors. Huge thanks to PCBWay for sponsoring this episode and sending over these beautiful boards. I am so relieved I didn't totally mess up, and all of these PCBs can still be used without modifications. In fact, I'll put another one together for the Z-axis, so only the X and Y-axis remain converted to bipolar. Like I said, if you guys are interested, I'm going to open source Chronic Unistep. Maybe someone else can come up with a better solution to changing direction that doesn't make the stepper do random unwanted steps. Also, special thank you to my supporter on Patreon, and as a treat today, I'm not gonna bore you guys with another ad for my page there. I hope you enjoyed this video. I'll see you again sometime next month with the results of my research into making a heated bed for under $10. Sounds easy, right? Just slap on some heater wire and be done. But it's actually extremely difficult, so stay tuned. Bye bye!